Sarah closes her eyes at 11:47 p.m., thinking sleep is just switching off. But what happens next is one of the most enduring mysteries of neuroscience. In the next 7 minutes, her brain will hit a tipping point and begin fundamentally rewiring itself in ways science is only now understanding. But 23 seconds after Sarah's eyes close, her brain begins a violent civil war. What she thinks is a peaceful drift into unconsciousness is actually a brain that looks asleep, but a heart that looks awake. Different regions of her mind shutting down in precise sequence while others fight to stay online. Her prefrontal cortex, the part that handled her work emails and dinner decisions, starts dimming first. But her emotional centers, the amygdala and limbic system, surge with activity as if sensing the approaching void. Sarah's brain regions aren't cooperating. They're competing. This isn't the gradual fade she imagines. Her consciousness doesn't slide away smoothly. It fractures into competing neural territories. Her thalamus, the brain's relay station, flickers between wake and sleep states dozens of times in these first minutes, orchestrating its own controlled demolition. Meanwhile, her hippocampus begins firing in sharp bursts, replaying fragments of her day at 10 times normal speed. The marketing presentation, the coffee spill, her sister's text message. What feels like simple tiredness is actually Sarah's 86 billion neurons waging microscopic battles for control. Some regions surrender immediately, others cling to wakefulness with desperate electrical storms. Her visual cortex dims. Her motor cortex goes quiet. But her limbic system keeps surging, keeps fighting, as if her emotions refuse to accept what her body already knows. And in the chaos of this neural competition, something extraordinary begins. Her brain starts rewriting itself at the cellular level, preparing for a transformation that will make tomorrow's Sarah fundamentally different from today's. 3 minutes into Sarah's neural battlefield, something unprecedented begins. While her consciousness fragments and her brain regions war for control, her hippocampus starts actively transferring newly acquired memories to cortical networks. But not all memories. Sarah's brain is performing surgical triage, deciding which moments from today deserve permanent storage and which will be deleted forever. The coffee spill at 2:17 p.m., gone. Her sister's worried text about their father's health, preserved. The marketing presentation that felt so crucial this afternoon. Her brain weighs it against everything else, measuring its emotional intensity, its connections to existing knowledge, its potential future value. This process involves curtailing weak synaptic connections while sparing stronger ones, thereby increasing signal-to-noise ratios within neural networks, essentially deciding which version of today's Sarah gets to survive into tomorrow. This isn't passive storage. Sarah's hippocampus and cortex engage in coordinated neural activity that includes sharp wave ripples, slow oscillations, and thalamocortical spindles, creating a biological editing room where memories compete for permanence. Her brain replays today's experiences at 10 times normal speed, but each replay is different, strengthening some neural pathways while allowing others to decay into oblivion. What Sarah experiences as simple rest is actually the most consequential editing process of her day. By morning, entire chunks of her lived experience will have vanished as if they never happened. Other moments will be crystallized with startling clarity, woven permanently into the fabric of who she is. Her brain isn't just resting, it's rewriting her personal history, one synapse at a time. 5 minutes into Sarah's transformation, her body enters the most dangerous phase of sleep, a state that should have killed her species long ago. Her muscles now begin to shut down completely. Her body temperature drops. Her breathing slows. Her ability to respond to threats plummets to almost nothing. This is the evolutionary gamble that defined humans. While other animals evolved lighter sleep or shorter cycles, our ancestors doubled down on the most dangerous state imaginable. They didn't evolve to sleep less or sleep lighter. They evolved to go deeper, to become more defenseless, to surrender more completely to unconsciousness. Early humans on the ground, vulnerable to predators and hostile rivals, made a bet that no other species dared make, that the transformative power of deep sleep was worth the risk of total vulnerability. Sarah's brain is now forcing her into exactly what kept her ancestors alive, not despite the danger, but because of it. The deepest sleep stages weren't a luxury our ancestors could afford. They were a necessity so profound that humans were willing to become completely defenseless to achieve them. While Sarah lies motionless in her Denver bedroom, her brain is performing the same impossible biological maintenance that convinced our ancestors to risk everything. What Sarah experiences as peaceful rest is actually the most counterintuitive survival strategy in the animal kingdom, trading maximum vulnerability for maximum neural efficiency. Her ancestors survived not by avoiding this dangerous state, but by making it so transformative, so essential to who they became, that the risk was worth taking every single night. 6 minutes into Sarah's transformation, her brain begins the most profound rewrite of all. While her body lies motionless and her memories sort themselves into permanent or temporary storage, something even more fundamental starts happening. Her synaptic connections begin widespread down-selection, a process where weaker neural pathways are eliminated while stronger ones are reinforced. Sarah's sense of self is literally dissolving and rebuilding at the cellular level. This isn't just memory maintenance. Her brain is transforming memories into more abstract representations, stripping away the specific details of her day and keeping only the essential patterns that will shape who she becomes tomorrow. The marketing presentation she stressed about isn't just being stored or deleted. It's being abstracted into broader lessons about handling pressure, communicating with colleagues, managing deadlines. Her brain extracts the underlying rules and discards the surface details. Meanwhile, sleep oscillations coordinate the flow of information across her brain networks, orchestrating which aspects of today's Sarah get integrated into tomorrow's version. Her hippocampus and neocortex engage in a complex dialogue with repeated neuronal replay of encoded representations working alongside brain oscillations to regulate information flow. Each replay cycle strengthens certain neural pathways while allowing others to fade. What Sarah experiences as peaceful unconsciousness is actually the most active personality reconstruction process her brain will undergo. By morning, the neural architecture that defines her preferences, her emotional responses, her decision-making patterns will have been subtly but permanently altered. The woman who wakes up will carry the same name and memories, but the underlying structure of who she is, the very foundation of her identity, will be different. This is why sleep deprivation doesn't just make you tired. It disrupts the active systems consolidation process that transforms daily experiences into long-term personality changes. Without these nightly rewrites, Sarah would remain trapped as yesterday's version of herself, unable to grow, adapt, or become the person her experiences are shaping her to be. 7 minutes into Sarah's transformation, something unprecedented happens. While her body lies defenseless and her memories reorganize themselves, her brain accomplishes what no other species has mastered. It rewires itself to become better at the very thing that makes her most vulnerable. This is the paradox that defines human consciousness. Sleep is the price Sarah's brain pays for plasticity. Every night, her brain chooses to become completely helpless because the transformation it undergoes during sleep is so profound, so essential to who she becomes that no other state can achieve it. The risks are staggering: defenselessness, vulnerability, the complete surrender of awareness. Yet Sarah's species didn't evolve to sleep less or lighter. We doubled down on vulnerability. What Sarah experiences as unconsciousness is actually the most sophisticated biological process on Earth. Her brain isn't shutting down. It's performing surgery on itself, editing her neural architecture with microscopic precision. Weak synaptic connections decay while essential ones strengthen. Memories that seemed crucial this afternoon, the marketing presentation, the email chain, compete against deeper patterns for permanence. Some win, most lose. By morning, entire chunks of today will have vanished as if they never happened. This nightly death and rebirth is what makes us human, our willingness to surrender consciousness completely, to become utterly defenseless for hours at a time, represents our species' greatest evolutionary gamble. Tomorrow's Sarah will be built from tonight's neural reconstruction, a slightly different version of herself, shaped by today's experiences but freed from their unnecessary details. She will wake transformed, and she will do it again tomorrow night, and the night after that for the rest of her life. This is not rest. This is becoming. Subscribe for more hidden truths. Next, what happens in the 30 seconds before you wake up?